It's the last thing we're going to do this week. It's still the same section we did yesterday. It's just the second part of the section. So 3.5, part 2. Okay, first thing, can somebody remind me, and we did this in the warm-up, what does an equation look like if it's in slope-intercept form? So I'm looking for something that has all letters. Yep. Right. It's y equals mx plus b. So when you write something in slope-intercept form, and you've got to make sure we know what the m and the b are. So can someone remind me again, what's the m? Sophie? That's your slope. The slope can be a positive number, it can be a negative number, sometimes it's a fraction. And what about the b? Yep.
Y-intercept.
The b is the y-intercept. Okay, so that's the first part of your guided notes. Just writing that formula down. Okay, does everybody have that part? All right, so we know how to graph an equation if it's like this. This is what we did on Monday. To graph something that's like that, we found intercepts. Actually, I think that's the same problem. Yeah, actually, it's this one right here. To graph an equation that's set up with the x's and the y's on the same side, you find the intercepts. You plug 0 in for the x, and then you solve, and then you plug 0 in for the y, and then you solve it again. And that will give you the 2 points that we just found in the warm-up. Once you have the 2 points, you draw your line through it. When we graph in y equals mx plus b, that's a little different. We're going to use the slope to help us. Okay? When you're doing the other kind, you don't have the slope, so you can't use it. But we're going to have the slope, and that'll help us. So to graph an equation in y equals mx plus b form, step 1 is make sure it's in that form. It can't be like y plus 2 equals 3x. That is not slope-intercept form. You need to have the y alone. So that's step 1. Make sure it's in y equals mx plus b form. If it's not, you need to fix it so it is. Okay, so that goes on the 3 lines that you have where it says 1. That's what you want to put on line 1. Make sure your equation is in y equals mx plus b form. Now, I'm not going to go through and do this whole problem, but can anyone tell me what I would have to do on both sides to get the y by itself there? Yep.
Subtract 2.
Yep. You'd have to subtract 2. Okay, we'll practice that, and we did already practice it, but we'll practice that again today. Step 2. Once you have it in y equals mx plus b form, let's use the one above. If we did what Abby said, that's what you'd end up with by subtracting 2 on both sides. Now, you're going to be able to see your y-intercept because you have it in the right form. This number is the y-intercept. The sign to the left always goes with the number. It's like it's attached to it. So this has a y-intercept of -2. We would put a dot on -2. That's the second step. Put a dot on your y-intercept. The last step is going to use the number 3. What's the 3 again? That's my Sean? That's my slope. And remember what we said about slope. There's a formula for it. 2 words that begin with an R. Does anybody remember what's the formula for slope, Madeline?
Rise over run.
Right. It's rise over run. Well, I'm looking at my slope, and it's not a fraction. But what number could I put underneath 3 to make it a fraction? You can put any number. You can put this number in the bottom of anything, and it makes it a fraction. Yep, a 1. So what this means is my slope has a rise of 3 and a run of 1. So it tells me how far up to go and how far right to go. So the slope is like directions. Directions from where? From right there. So once we graph our y-intercept, from that spot that you just graphed the y-intercept, use the slope to get another point. Remember, the slope is like directions. It's going to tell you from the y-intercept how far up to go and how far over to go to get another point. Now, sometimes you might have a problem like this, where the slope already is a fraction. If it's already a fraction, then you're going to be able to see your rise in the top and your run in the bottom. But if the slope is not a fraction, what number did we just say you could always put in the bottom to make it a fraction? Right. You could always take a number that's not a fraction and just put it over 1. So there's no spot for that on your guided notes, but you may want to write it down right below line 3 if you don't remember that. But you can always take a number and put it over 1, and that makes it a fraction. But only if you need to. It might already be over a certain number, like this one's already over 3, so it's fine, it's a fraction. And this is the other reason why we don't write slope as a decimal. Because 2 over 3, the number 2/3, that's like 0.6 repeating. Well, if we wrote it as 0.6, it doesn't really tell us directions anymore, like up and down and left and right. So always leave your slope as a fraction. And just a review of which directions are which. For a negative slope, you would go down, and then you go to the right. That's how we would do our rise over run. Down and to the right. If it was a positive slope, it would be up and to the right. So we count up, and then we would count right. So I'm either going down and right or up and right. So I always go to the right, always. It's just a matter of, do I go up or do I go down? The only time I wouldn't go to the right is if, for some reason, my graph was right on the edge of the right side of my graph paper. Let's say you made a mistake and you didn't put your graph in a good spot. So let's say you had a point right there. And I had to count from that point up to right 5. Well, that's going to be kind of hard to do because now I'm going to go off my graph paper. So instead of counting up to and right 5, I would have to do the reverse. I'd have to count down to and left 5. It's the same thing. I just don't have enough room to go up to right 5 and end up over here. So that's why I try to avoid doing a problem on the right edge of a piece of graph paper. Do it more to the left or do it like in the middle. And that won't be a problem. Questions on those 3 steps? Let's try a couple examples. All right, it says graph the linear equation, and then it says to identify the x-intercept. Okay, for some reason they want the x-intercept, they don't want the y-intercept, so be careful with that. It's probably going to be easier to get this after we draw the picture. Okay, so if we were doing this like we did it on Monday, we'd be plugging in a 0 and then a 0. But today, we want to rewrite it. How do we want the equation to look? Just with all letters. We want it to be like y equals, yep,
mx plus b.
we want mx plus b. So the first thing we always do to get it in y equals mx plus b, if you need to do anything, and here you do, is you deal with the number with the x. We want the number with the x on the other side. So how would I move the 6x to the other side? Got 80. Yep, good. By subtracting 6x, subtracting 6x. Jacinda, what's 6x minus 6x?
0.
0. So this is gone. Tirza, what's on the left-hand side now? 3y. So it's better. It still doesn't have y by itself. There's one more thing we have to do, but it's better. And how am I going to write what should go on the other side? We want to write it, but make sure we put it in that order. Yep.
Negative 6x minus 1.
Right, they're both negatives, but you want the one with the x first. So put the negative 6x first, and put the negative 12 last. Cadence, is that y equals mx plus b now? No, there's still something wrong. What still is on the left side that we do not want? We don't want the 3. So how am I going to get rid of this 3 that's next to the y? Caleb? Well, if we subtract it, we can't combine these because they're not like terms. This is 3y, that's a 3. If you were to do that, you just end up with this, 3y minus 3. But instead, you said we want to do what? Yeah, we want to divide it. Where else do I have to divide it? Yeah? Right, the negative 6x and the negative 12. Some people forget when we divide, you have to do it in all 3 spots. The left, middle, and then on the right. All right, Anaya, what's 3y divided by 3?
0.
Yeah, y, right? 3 divided by 3 gives me 1. So essentially I have 1y. And Sophie, what about negative 6x divided by 3?
Negative 2x.
Good, negative 2x. And the last part, negative 12 divided by 3. Alyssa, tell me what that would be. Negative 4. Okay, so now we have an equation that's going to be good to graph using the way I'm showing you today. It's not that the way I'm showing you today is better than than Monday. It's just different. Just different. We're not plugging in zeros today. That's a good way to do it, just not for the one we're doing right now. Okay, so we got step 1. What's step 2? On notes we just put.
To graph the y-intercept on the x-axis.
Graph the y-intercept on the
X-axis. Oh, y-axis.
y-axis. Okay, what's my y-intercept here? So, Monica, what's my y-intercept?
-2.
That's my slope.
-4.
-4. Okay, so -4 is my y-intercept. And all we're going to do is put a dot on -4. All right. And Nia, what does step 3 say? So that was step 2. We got the y-intercept. Right, we have to find another point on the line, and what are we going to use to do that? Right, we're going to use the slope. So, from the y-intercept, use the slope to get another point on the line. So my slope is -2. But I need to think of my slope as a fraction, so I know how much up and down or how much left and right. So how can I think of -2 as a fraction? Yeah. Yeah, just put it over 1. All right. So now, Maya, what's my rise in that slope?
-2.
My rise is -2. What's my run?
1.
1. So my rise is -2, and my run is 1. So from this point, do what the slope tells you to do. The rise is -2, and the run is 1. What's a rise of -2 mean? Down 2. And then I said I always go down, and then which way? Right. We're going to go down 2, and we're going to go to the right, how many? 1. So from this point, it has to be from this point. Down 2, right 1. If you want to do it again, you can. Down 2, right 1. I mean, you can do it as many times as you want. And this is what I mean, like if you had to keep going, you don't have any more space on your graph. You ran out of room. So if you wanted to go back the other way, you could do the opposite of what you just did. Instead of down 2, right 1, go left 2, up 1. Left 2, whoops, left 2, up 1. Left 2, wait a minute, what is it? Down 2, right 1, so up 2, left 1. There we go. That's way more points than you need. I mean, I do 2, and then I just draw my line through them. The only reason I would do that many is if I didn't have a ruler and I wanted to try to draw it as straight as I could. Well, now I can do pretty good. So that's how you do it. So when you check any 2 points, it should always be down 2, right 1. Down 2, right 1. Down 2, right 1. I think I messed up one right here. It should be down 2, right 1, but that's okay. That's why there's a little bit of a bump in the middle. Question on that idea. So it's really 3 steps. Get it in slope-intercept form. Graph your y-intercept. And then use your slope to get another point on the line. You only need 2. I usually do 3, just to have an extra one. All right, so why don't you guys try that one? So just like the last one, see if you can get it in y equals mx plus b first. Then put a dot on your y-intercept. And then use the slope to try to get one more point. Look at it. Okay, so if we were graphing this like we did on Monday, then we would do the 0 for x, 0 for y. This is just a different way to do it. Is this equation in slope-intercept form? Okay, no, we need y by itself for that. So can you tell me the first thing you would move to the other side?
Add 4x.
Add 4x to both sides? Okay. So let's add 4x, add 4x. What's 4x plus 4x? Yep, that would be 8x. Okay. And we'd still have the 2y. And what would you have on the other side? Yeah, you could write 2 plus 4x, but we want to put it in the order that we're used to. So 4x plus 2. Okay. Now what? I think we were supposed to subtract 4x to start. Yeah. Let's try that instead. So let's subtract 4x. Subtract 4x. And now 4x minus 4x is gone. That's what we wanted to happen. So we have negative 2y equals. And Natalie, what's going to be on the right side?
2.
Can you just put it in y equals mx plus b for me? Well, it's not y equals yet, but at least put it in mx plus b on this side.
Negative 4x minus 2? No, plus 2.
Plus 2. That's a negative 4x. That's a positive 2. We're just putting them in a different order. Negative 4x, positive 2. Okay, it's close to y equals mx plus b, but one thing left we have to do. What do I still have to get rid of to get the y by itself? Sean? The negative 2. And can you tell me how I would get rid of it?
Both sides.
Yep, and when you say both sides, you mean here and where else on the other side?
4x.
Okay, where do I do it on the right? Yep. On the negative 4x and the positive 2. We do it in all 3 spots. Okay, so that's going to just give me y equals. What's negative 4? Well, what's going to happen here? Negative divided by a negative is a positive. What's 4x divided by 2? X divided by 2. Okay. 2, and what letter goes with it? X. And what's 2 divided by negative 2? Yeah. Negative 1. Now, while I'm looking at my slope, I'm going to make it a fraction right away because I know I'm going to need it to be a fraction in a minute. So I'm just going to put it over 1. Okay. What is my y-intercept? Here's it. Negative 1. And from that point, can somebody tell me which way I go to get another point? Up to and over to the right one. So up to right one. You can do it as many times as you want. And draw your line as best you can. Mine's a little off, but I'll fix it. That looks pretty good. Now, I know it's a little hard to see, but does anybody think they see where it crosses the x-axis? Yeah? It looks like it's a half. I mean, I'm not going to give you something that would be like 0.4 or 0.2. I mean, it's either going to be a half or it's going to be a nice number. So this one looks like it's right in the middle between 0 and 1. So the x-intercept is 1/2. All right, so the last, let's see, yeah, we're on the back, last problem. So the last problem, example 2, it's just a matter of understanding how they're wording it. It's nothing you haven't already done. Yes?
Can I get a drink of water?
Yeah, just stay out for me, go ahead. Okay, so let's read through it and then see what it's telling us. But you're going to end up doing this problem exactly the way you did this one. And once you know the wording, this problem is actually faster than the last one. So it says we have a linear function, which means we're going to be drawing a line. Linear means straight line. In which the y value goes up 3 for every 1 unit the x value goes up. So think about that. The y value is going up 3 for every 1 unit the x value goes up. What do you think this is really telling me? It's telling me up 3, right 1. That's really my what? That's your slope. Y value is the rise, so think of it that way. It says the y value goes up 3, increases by 3. For every 1 unit, the x value goes up. So we're going up 3, right 1. So these two numbers are your rise and your run when you see it worded that way. The number with the y value is the rise. The number that is with the x value, they call it the independent variable, but then I put in parentheses x, so you know which one it is. The number with the x is the 1. So we've got our slope. But what did we need in the last problem before we had the slope? We needed something else. Yeah? You have to have the y-intercept. And that is what that's telling you. When you see something like this was called function notation. So we had some formulas maybe last week where we said instead of writing y, you can put in f of x. So this part, that's like your y. That's your x. So that number right there is an x value. So when you see something like this, you can think of it as all it's telling you is a coordinate. This is another way you can write down a coordinate. Okay, we usually write it this way, but if you see something written like that, it's just another way of writing a coordinate. And this really is the coordinate of my y-intercept. The x value is a 0. And we learned when you find the y-intercept, the x value is supposed to be 0. And here's my y value, 2. How did they get this y value? Well, we don't know. They just gave it to us. We don't actually have a formula in this problem. All they're doing is telling me the slope, and then they're telling me the y-intercept. That's what those two pieces of information are. So what's my y-intercept? just like that. 2. My y-intercept is at 2. When it says f of 0 equals, the number on the other side is the y-intercept. 2. And now from the 2, which way am I, how do I get another point? What are my directions to get another point? Yeah, Abby?
Up 3 over 1.
Yeah, the y value goes up 3, and the x value goes over 1. Up 3 over 1. And then draw your line. Okay, so just a little bit different wording, that's all. So when you see this thing about increasing 3 units for every 1 unit, that's your slope. When you see f of 0 equals a number, that number is your y-intercept. They're just not saying it that way. It's the same thing. All right. So homework tonight is 3.5 part 2. Remember, there is a reference sheet on Schoology. You don't have to do the reference sheet if you want to do it. I said that it would be worth extra credit. So I'll give you 7 points extra credit if you do the reference sheet. So you have to do the homework, but you don't have to do the reference sheet. And it's already posted. It's there right now. Okay. So any questions on that? And this is our first test that will be on quarter 2.